Hey everyone, my name is Maury Limatainen and I'm originally from Sudbury, Ontario, Canada, and I'm living in France. And as part of my week one assignment of the Coursera Introduction to Music Production class, I'm going to teach you a little bit of what I know, at least, about a couple of different types of microphones. The two types of microphones that I'm going to be talking about today are first a dynamic microphone, and second of all is the condenser microphones. So I think to start, it's important to mention the microphones are also known as transducers. And what a transducer does is it converts one form of energy into another form of energy. So in the case of a microphone, you would have acoustic energy being transformed into electrical energy. By comparison, a loudspeaker would be doing the exact opposite of that. You would have electrical energy being transformed into acoustic energy. So as I mentioned, the two main types of microphones that I'm going to be talking about are the dynamic and the condenser microphones. And the dynamic microphone that I'm going to talk about first is this. Um, we're all familiar with this one. It's often used in stage applications, but it's also used in many studio applications as well, depending on what we need to use it for. Dynamic microphones are very rugged. They will take a lot of abuse, both physically, whether it gets dropped, which happens from time to time, of course, and also they are very rugged in the sense that if a singer is singing very loudly into it, or an instrumentalist is playing loud into it, they'll be able to withstand that broad dynamic range that will be required to be able to reproduce that without too much distortion. Now, the way that a dynamic microphone works, it's a little bit difficult to see here, but there's actually a membrane here, and to that membrane is actually attached a coil of wire, and as the sound comes into the microphone, the membrane vibrates, and the vibration of the membrane causes the coil to move in a magnetic field, which then induces a current in the wire. So that is your acoustical energy being transformed into electrical energy. Very simple process. In fact, if you have a set of headphones, it's doing exactly that, except in reverse. In fact, if you wanted to, I've never actually tried it myself to see what kind of sound quality it is, but you could literally speak into your headphones if you had it plugged into your microphone input and actually get some kind of a signal. As I say, I've never tried it, so I don't know exactly what kind of quality you're going to get out of that, or how good the reproduction will be, but it is literally the same thing. Now, the second type of microphone that I want to talk about is a condenser microphone. Another word for condenser is a capacitor, and those of you with an electronics background will know that a capacitor is actually made up of two plates. So what I have here is what's known as a large diaphragm condenser microphone, and I've already loosened the screws off it, so I'm going to gently take off the cover here, and you can see here and here there are actually two metallized plates. Now, what happens is the sound will come in and they will strike the plates, and the physical relationship between the two plates will change, affecting the capacitance, which is then used to generate the electrical signal. So, a little bit different than a dynamic microphone where the actual movement of the membrane generates the electrical signal. Here, the movement of the membrane changes the capacitance, which is then converted into an electrical signal. I think it's important to note that in a large diaphragm condenser microphone, it requires a 48-volt phantom power signal from generally the mixing board, and what that does is it actually provides electricity to charge up the plates. In the case of a dynamic microphone, there's no power like that required. So that is one difference between the two types of microphones. So there are certain advantages and certain disadvantages to condenser microphones. I think generally speaking, condenser microphones are regarded as being more accurate microphones than dynamic microphones. so as a result, more often than not, you will see condenser microphones used as vocal mics, as an example, in a studio application. That's not necessarily always true, of course, but quite often that will be the case. They give you some flexibility. I'll see if I can position it so you can actually see it. Quite often condenser mics, or certainly a large diaphragm condenser mics, will give you some flexibility in terms of the polar pattern. So for example, the position that the switch is in right now, it gives you figure 8 pattern. So you will have a node in front, or a lobe rather in front, and a lobe in back of the microphone. You can change it to a cardioid, which will exclude sound from the back of the microphone. And the last position is an omnidirection, which is an equal distribution of how well it picks up from as far as the polar pattern is concerned. This particular one gives you also a high pass option. Again, hard to see in that picture, but you can drop off the low frequencies or just leave it in its normal position. There are some distinct disadvantages to this particular type of condenser mic. There are other types of condenser mics, but they are also, or not there. They tend to be less rugged than a dynamic microphone. So you won't often see, in a stage application at least, a large diaphragm condenser being used by a lead singer, for example, for a few reasons. A, they won't withstand the dropping that they inevitably will, that inevitably a stage microphone will see, but also they won't withstand the really loud dynamic, or really broad dynamic ranges that will often be demanded in a stage application. So that's it in a nutshell for dynamic microphones and large diaphragm condenser mics. There are no hard and fast rules in terms of what you could or couldn't use in whatever types of application. Ultimately, the choice is yours. You really do need to experiment to figure out what's going to give you the best sound. But at the same time, you also don't want to have to be replacing your mic every gig. So there's certain considerations in that regard. But ultimately, the best rule here is use your ears and use the one that sounds the best for your application. Anyway, hopefully you've learned a little bit more about these types of microphones, and we'll see you next week. Thanks very much for listening.